job of calling you Mitch. Mitch, are you chewing gum? Okay, good. Oh, that's not good. Yes, sir. Oh, absolutely. Hey, listen, Blake just brought up a great point. We're going to listen to that great point. He said, hey, I did my factoring a little bit differently. There's probably about 4 different ways to factor this particular type of trinomial. Okay, so whatever floats your boat. I highly recommend you do you. You're not a bunch of little Morgan math robots where you do it the way that I do it. So yes, absolutely. If you factored a little bit differently, that's not a problem. But Mitch was going to do the zero product property.
So you would do x plus 2 equals 0. 3x minus 1 equals 0. And so for the x plus 2, you just subtract 2 from both sides, so you get x equals -2. And then for 3x minus 1, you add 1 and then divide by 3, so that's 1/3.
Perfect. Now, a couple comments. All right. Oops. How many solutions did that quadratic equation have, Denegri?
2.
It had 2. And we talk about the word quadratic in here, yes?
Yes, sir.
How it comes from the Latin word quadrus, meaning
4.
2. I don't remember.
Wait, I think
square.
5 minutes.
Did we not talk about that? Did we? I thought we talked.
BJ, aren't you in live?
It's all good. Hey, brush off the fingers. Okay. No, the word quadrus in Latin means square. And so when I see an x squared, that's a quadratic equation. How many solutions does every quadratic equation always have? 2 solutions. So Mitch just helped us find those 2. They were rational solutions because this was a factorable quadratic equation. We solved it using factoring in the ZPP. That's okay, good. So if this didn't factor and we had to use something like the quadratic formula, which we'll talk about today, or completing the square in the square root method, or the calculator, a rational number is a number that could be expressed as a terminating or repeating decimal, a number that could be expressed as a ratio of integers or a fraction. Irrational would not be. So like, for example, if I wanted to come up with a real simple quadratic equation like x squared equals 7, that's a quadratic equation. It has 2 solutions. They're just irrational. Here, x would equal square root of 7 or negative square root of 7, right? Neither one of those is a rational number. I can't express them as a ratio, but they're still solutions, okay? So here in red, what we had was we had an equation that had 2 solutions. Now, if a quadratic equation has 2 solutions, how many solutions does a cubic equation have? 3. Good. That's per the fundamental theorem of algebra. Fundamental theorem of algebra says that a polynomial equation of degree n is going to have n solutions. All right? That's a fun fact. I would write that down. The fundamental theorem of algebra says that a polynomial equation of degree n will have n solutions. Okay? So if I gave Finley like a degree 5 polynomial equation, and he knows it's going to be 5 answers, he might not, at this current juncture, might not be able to find all 5 answers, but he could find 1 or 2 of them, and then one of the things we learned to do this year is to solve degree 5 polynomial equation and to find all 5 of those answers. And like right now, you might only be able to find 1 or 2 of them. But then I'll show you some techniques like synthetic division, where we can kind of peel back the layers and find the others. Like an onion, that a boy. Man, I'll tell you what, I cooked up a mean onion the other day.
Did the
I'm thinking about the blooming.
I hear you.
the stuff fraction.
Or the awesome,
like peel it back first before you dip in.
the awesome blossom at Chili's. I want an awesome blossom.
I think onion. I think
Extra awesome.
The game called
That's the blooming.
I chopped up an onion. I chopped up a pound of bacon the other day and fried it up in my cast iron skillet with some seasonings. And then I did a whole bunch of rice, threw my rice in there, scrambled up some eggs, threw that in there, and I put some sesame seeds and some soy sauce. We had bacon and eggs fried rice. Anybody ever done that?
Southwest.
Oh, it was good. All right, I digress. Square root of 18. I want to go back because there was something I didn't do with you guys. Does anybody know how to simplify that, like by hand?
Yes. Yeah.
What goes into that that's a perfect square? Good. So y'all have been taught to rewrite the product 9 times 2 as the product, radical 9 times the radical 2, and get 3 radical 2. Is everybody comfy doing something like that? If you're not, it's okay. We're gonna practice stuff like that. But being able to simplify, Mr. Perry hit y'all up hot and heavy. If you had him last year in honors geometry, hit y'all up hot and heavy with radicals like that. That's one of the prerequisites for getting into that honors geometry class, is that you're good at radicals. We're gonna do a lot of that kind of stuff this year. So that was a little extra icing on the warm-up cake here. But now I want to jump on down into square root of 108. Did anybody spot the biggest perfect square factor that went into 108? 36 times 3. All right, now what about that x squared? Cuidado.
Take it out.
So
6x times.
you think 6x radical 3 is your correct answer?
Yeah.
I do.
Now that I'm phrasing it that way, you might not. That is not the correct answer. Get it? It is not that. Now, good, valiant effort, everybody. Instead of going around the room and sort of cherry picking, what do you think it is? What do you think it is? What do you think it is? I'm gonna leave you in suspense because we're gonna talk about this in just a moment. All right, but this is not the correct answer. You guys watching at home, this is not the correct answer for number 5. Okay, but I'm gonna leave you in suspense. Dun dun dun. We call that a cliffhanger. All right, number 6. Let's jump back on into our warm-ups. We'll put a big fat question mark next to number 5. Number 6, Nicholas, what do you want to do to both sides? You're a man after my own daggum heart. Okay, so we'll work this 2 different ways. He's going to factor it out as 3x plus 5, 3x minus 5, getting how many answers? 2 answers. Mitchell Gilmore, what's the relationship between those 2 binomials? I know, but there's a vocab word starts with the letter C. Not a bad guess. No, they're not correspondent. Anybody remember the vocabulary word? What's the relationship between these 2 binomials? Who said that? Mario, that's a bonus point. Good for you. Conjugate. They are conjugates. That is going to be a very useful vocabulary word in this chapter. The word conjugate. So like A plus B and A minus B. That's what conjugates are. And did you notice what Mitchell said regarding those conjugates? I got to slow down, by the way. I'm getting a little icky here. When you multiply conjugates, what was the result? Not a trinomial, in other words, a binomial. So going back to, who is my FOIL master over here? Michael I can't read straight. Estave. Estave? Okay. Anywho, Michael. Michael mentioned a minute ago with FOIL, we do first, outer, inner, last. What happens to the FOIL problem when you're multiplying a binomial times its conjugate?
2 inner values. Add up.
The outer and the inner cancel each other out. That's going to be a really helpful notion. And by the way, look, we're having a good discussion, and you guys have been trained by the best. Coach Cannon has discussion-based classes. Y'all have had Coach Cannon's classes before. Some of you have, maybe. You probably want to write a lot of the things down that are getting said in our discussion that are not necessarily on the screen. I highly recommend that kind of note-taking prowess. Okay. So, Nicholas, Finley, put your foot down. Nicholas has got this factored out so we could apply the ZPP. Stephen, what would our 2 results be, our 2 answers? Good. Now, I am going to push you guys this year, figuratively speaking, I am going to push you to go from this step to the answer. This step to the answer. Binomial in the parentheses to the answer. That is my goal. I'm going to be pushing you to get there. If you're not there yet, that is okay. Take your time, show your steps, subtract 5 divided by 3, add 5 divided by 3. But we could save a lot of what? Time by getting comfortable going from a factored out product using the ZPP, just like Mitch did a second ago, to our answers. Okay. Now, would anybody like to propose, Mitchell, close your laptop, please. Would anybody like to propose a secondary way, Danae, maybe, of working this problem out? Not using factoring in the ZPP? Andrew is on the ball here. He's got it. What do you think, Andrew? That's what we did in blue. Well, maybe Finley? You know what to do? Okay, that's what I'm shooting for. Yeah. Ready? Feel good with that? Okay. Mario, you saying the same thing? Look, if I add 25, I get 9x squared equals 25. And then divide by 9, I get x squared equals 25 ninths. Now, what we're going to talk about today in class, Jack, is that there's an inverse operation to squaring. What do you think that is? Jack. Square root. Very good.
Oh, you were paying attention. Like,
Well, BJ, let me take care of my own business. I called on him because I knew he knew what to do. Anyway, here we go again. This is like number 5. We've got the square root of x squared. Beard stroke, beard stroke. What does the right-hand side equal? 5/3. And yet, ooh, voice crack. And yet, this was what kind of equation? Latin scholars? Quadratic equation. How many solutions do we already know the quadratic equation is going to have? 2 solutions. So what the dump? Where did my 2 solutions go?
plus or minus.
Well, if we wanted to skip over an intermediate step. So in other words, the square root of x squared does not equal x, because if I just wrote x, then I've only got one answer. It equals the what of x? The absolute value of x. And now we could say, oh, well, x must equal plus or minus 5/3. Now, I said that Nicholas was a man after my own heart because I'll be honest with you, if I can factor, I like factoring better because it physically puts 2 parentheses in front of your eyes. Dadgum, you know how many times I get kids that will take the square root of both sides? They'll use the square root method and then they'll only tell me x equals 5/3 because they'll forget the plus or minus. Happens all the time. It'll happen in this class. One or more of you guys sitting right here in this room will forget the plus or minus at some point in time this school year. It just happens. Eli.
What is an absolute value in the answer like x? X will have.
Definitely matters. Great question, Eli. If you didn't hear that, he said, does it matter where the absolute value goes? It absolutely, no pun intended there, absolutely does matter. It goes on the x because a square root is a non-negative value. And so just like I asked you guys, I think Sebastian, just like Sebastian helped me with number 1, he didn't deadgum say, well, the square root of 64 is the absolute value of 8. He just said it's 8. Just like when we were right down here, we're saying the square root of 25 ninths is 5/3. The absolute value gets hit up on the variable side of things. It's hit up on the variable side. Nicholas, follow up.
But the difference in squares when once you subtract to that you said if you're doing the adding, you have to do.
Welcome to Algebra 2. In Algebra 2, you learn how to make things factor that don't normally factor. I'm going to teach you some cool stuff.
We're excited.
I know, it's so fun.
Our calculator automatically has I on it. So
Mhm.
it's the square root of -1, right?
And that's what we're going to talk about in this lesson or in this chapter 2.
Like I squared is like -1 plus.
We'll talk about that. Last but not least, what do you do for number 7? Add 32, take square root, get plus or minus 4 radical 2. Is that gravy with y'all? So Nicholas has hit upon the fact that number 7 doesn't factor as you would normally see it factoring in Algebra 1. Okay, So you would add 32. You would do like what Freddie and Mario and Finley and Andrew were talking about in the last problem. You would add 32, take square root, get plus or minus square root of 32. Square root of 32 has 16 in it. This is a warm-up problem you've already done, so I'm assuming you simplified square root of 32 and got 4 square root of 2. But just for kicks and giggles, I'll show you how to make this one factor. It doesn't factor over the integers. It factors over the real numbers. So this would be x plus square root of 32, x minus square root of 32. What's the, Fredo, what's the C word that describes the relationship between those two parentheses? Thank you, Alfredo. The conjugates. And when we multiply conjugates together, what happens to the oi? Cancels out. The outer and the inner cancels out. So we started with Sebastian. We'll go back to Sebastian. Sebastian, do the FOIL of those binomials, but just do the F and the L. Ditch the O and the I so we know they'll cancel out. What's F times F?
X plus,
First times first. What's X times X?
X.
Good. And then last times last? Ooh, don't go that route. Square root times itself, the square root goes away and you're just left with the radicand. So what's square root of 32 times square root of 32? That boy, yeah. And check this. Remember how we a positive times a negative? What should my operator be in there? Try again. Negative. Good. Right. And by the way, that's what we started with. You guys see that right there? You see that right there? So you're welcome, Nicholas. We can actually factor things that were originally unfactorable. And how can you check that factorization? By doing the FOIL. But because they're binomials that are conjugates, you can skip the O and the I, and you can do okay, the F and the L. All right. Now, take time out real quick. I'm going to be a little selfish. Can I be a little selfish? Yeah, BJ, you got something real quick? Oh, there you go. That's number 5. Remember how we were talking about putting the absolute value in with the square root of x squared? Is we'll talk about that in a little bit, but it's you got to include the absolute value. It needs to come out since it's a square root of x squared. It needs to come out. Square roots look for pairs of identical factors in the radicand. So like if I had, let me scroll over here. If I had like, for example, the square root of x cubed. Have y'all heard me describe the jailer approach? Anybody in here? Okay. So like this little guy up here on the edge, he's the jailer. And he says, I need 2 of you guys to get together and get out of this jail. Right. And so we would know x cubed is x times x times x. So the jailer's like, woohoo, there's 2 of you. You can get out jail. I'll write you once. And then, oh, so sorry, you're left in jail, Mr. X. We couldn't get you out. And so like that's how we would simplify the square root of x cubed. Okay. And then if it were something like x to the 4th, right? Couldn't we just say x, 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 pair up, and so what is that? X squared. You know what I'm saying? So it kind of works that way. BJ, does that help? All right, very good, very good. All right, I'm gonna be selfish. Oh, Kenneth, that's a $5 question. Great job. Absolute value is there to ensure non-negativity. Okay, and the fact that x in this example is still in the radicand, he was left in jail. Sorry, you didn't get out of jail. That assures that x cannot be negative. So that takes care of the assuring of non-negativity. So absolute value at that point would become superfluous. That's a good vocabulary word, Mr. Green. Do we know what superfluous means? Very good. Very good indeed. You know what? That's bonus point for having good vocab. Y'all like vocabulary?
Yeah.
All right, Finley? No. I'm going to be selfish just for a second, okay? We'll talk about that. Saturday, what's happening Saturday?
Football.
I am going on a mountain bike ride with the mountain bike team in Hernando, Mississippi. I'm going to be out in the woods. I won't be riding, but I'll be there. And so I won't have internet access. Now, why do I need to make sure I have internet access on Saturday? What's happening on Saturday?
Oh, football,
It's close, not college football,
baseball.
not NFL. It has to do with NFL football. Aha! Yes, my fantasy football league is doing their automatic draft. Hey, Coach Smith, what's up? Okay. All right. Well, I will step on outside. If you're watching at home, I'll be right back.
Like 20, about to get like no. Jack, you been Jack, you been try already.
Yeah, I just didn't go after the-
Eight in the league, whereas it's not in this class. Six.
Yeah.
You complete your range.
Yeah.
Well, I've never worked.
Never went to the Luther's Tennessee if I've never been nothing like actually, that's my own craft.
I go last 60.
You give me,
I was gonna play. I'm surprised.
I did fantasy basketball.
You need your players that you need to draft. And they're thinking.
Anyway, I don't know anything about professional football. And so I'm going to have to set my draft to do like the auto draft,
Look up a cheat sheet.
which is a dicey thing. Well, I respect y'all's opinions. I want you to give me 3 names that you would consider saying, ooh, coach, if you could get these 3, that'd be good.
Mahomes.
Is it PPR?
Yes, you get Mahomes, right?
Is it PPR? Is it points per reception?
I have no idea. I don't even know what that
If
means.
it's PPR, you go like,
CD Lamb.
you go CD Lamb,
CD
Somebody was telling me McCaffrey.
McCaffrey, if PPR.
He should be first pick.
Yeah.
Bro, Rushy Rice is like a late rat, it's like late round.
Not a quarterback.
Tyreek Hill, PPR.
Yeah, well, you're giving the top 3 picks.
He said name 3 players that he should get.
Yeah.
You're giving the top 3 picks.
Giving him the.
So are there cheat sheets? Are there lists of people that they say if you're doing fantasy league?
Like study fantasy.
Okay. So I can just look that up and then kind of allocate my thing. All right. Well, goody gumdrops. Now let's move on. You guys that are watching at home, I appreciate your patience. Here's some radical rules. This is a review. We mentioned number 1 a minute ago. The radical of a product is the product of 2 radicals. You can split that bad boy up. All right. But the root has to be the same. In other words, if I'm multiplying 2 radicals, if I've got like the square root of x times the cubed root of x, right? I can't multiply those 2 because that's like oil and water. It don't mix. So if it were square root of x times square root of x, we'd be gravy. We'd be fine. But if the root is not the same, you can't put them together. Freddie, you with me? Good. Sorry if I'm boring you. Let's see here. Rule number 2, if you're adding radicals, you got to have 2 things lined up. You got to have same root, but also you got to have the same radicand. So not only does it have to be, we're adding a square root with a square root, but it has to have the same radicand as well. So like, for example, square root of 2 plus square root of 3, I can't put those 2 together. Again, that's oil and water. Okay. But if I had square root of 3 plus square root of 3, then I just add the coefficients and I leave the radicand the same. Again, some basic radical rules y'all learned in Algebra 1. We're going to be using them considerably in Algebra 2. But here, lo and behold, here's my 3rd rule. And this is what you and I were talking about regarding absolute value to ensure non-negativity. Okay. So the square root of x squared equals absolute value of x. Definitely want to remember that. Square root of x squared equals absolute value of x. And then we've discussed it already to some extent, so I don't feel like diving deep into that. But really, if you did like a case-by-case basis, like if I picked a positive value and plugged that in, and I made this supposition supposing that that it only equaled like square root of a squared equaled a, right? You might say, well, it works for this one, and then it works for that one. But when you pick a negative number, it doesn't work. And so that's why you would have to insert your absolute value to ensure non-negativity. There in blue, I wouldn't necessarily write all that down, other than one of our, did y'all know this little predator symbol means therefore? Did y'all learn that from Miss Perry last year? 3 dots. This is math shorthand for therefore, the word therefore. 3 dots. And did y'all get the Predator reference? Like the movie with the little red dots where he's got his reticulated scope. I think that's a good word for that. All right. A couple more radical rules to make sure you're, again, this is algebra 1, but I feel bad if I didn't mention it because I don't want to assume everybody had, the same algebra 1 experience. Square root of a fraction, you can split the top and bottom, just don't divide by 0. And then if I'm dealing with a square root on the bottom or a cube root or whatever, it's bad form to have a square root in the bottom in algebra. In calculus, not so much, but in algebra, it's just sort of bad form. It's like, Phil, what do you do in your grammar class if you're writing a paper in English to start a new sentence? What kind of letter should you use?
Capital.
The capital letter, right? And so like I might ask, well, why do you do that? And you say, well, that's just proper form. That's just what you do. Okay. And so rationalizing, having a rational denominator, in other words, no square roots in the bottom. It's just kind of what you do in algebra. It's proper form, just like capitalizing a letter to start the sentence when you're typing stuff. And as a sort of little exercise here, I wonder if you could help me. Are y'all good at rationalizing denominators? We're going to find out. We're going to find out. How about 1 over the square root of 2? Does anybody already have that one memorized? What is it? Louder. No. Square root of 2 over 2. Good. That might have been what you meant. All right. What about square root of 3 on the bottom? What do you think that equals? Oh, y'all are fast learners. Good. Square root of 3 over 3. What about 2 over the square root of 3? Two times square root of 3 over 3. Good. These are all studied in trigonometry. This course that you're in right now is called Algebra 2/Trigonometry. And so we'll deal with stuff like that. So the question is, well, what the dump is going on here? How did these happen? Well, you're making use of what's called the identity property of multiplication. Michael, what could you always multiply by that doesn't change anything? Very good. That's our identity property of multiplication. You can always multiply by 1. And instead of 1, like the actual physical number 1, we can multiply by a clever form of 1, square root of 2 over 2, or square root of 3 over square root of 3. You know what I'm saying? Where we can, oh, it fell asleep. Shucks. Where we can just multiply the top and the top and the bottom and the bottom, and we wind up canceling out because, like I think Buckhold and I were talking a minute ago, what's square root of 2 times square root of 2? Just 2. And what's square root of 3 times square root of 3? Just 3. Okay. Now, was that too fast? Did I get a chance to get that? You think you're pretty good at rationalizing, and then you get something like this. Now, brown cow. Freddie, you gonna write this down? Let's go, Bob. 1 over 2, square root of 2 plus square root of 3. Now, Aiden, classify that denominator. Like it's got 2 terms in it. So what do we call that? You got a lot of bicycles in here. Bicycles have 2 wheels. So this one has a polynomial with 2 terms. So you would call it a what? It's a polynomial It has two terms, so you'd call it a bingo. Very good. And vocabulary words like that, fellas, you'll hear me use in class. And I just want to make sure we're all on the same page. Okay. So you got a binomial denominator. Is there any trick that maybe comes to mind that we've already discussed in this class that would help you get rid of those radicals? I'll give you a hint. Mario earned a bonus point regarding this. Ah. So, yes, sir. Somebody said Coach Morgan? Oh, soil patrol indeed. So, like, what are we going to multiply by? What's the conjugate? What's the conjugate of square root of 2 plus square root of 3? Square root of 2 minus square root of 3. Not reciprocal. Square root of 2 minus square root of 3. Now, interesting that you bring that up, Mitchell Gilmore. We have several words. We have opposite, reciprocal, inverse, conjugate. All of these vocabulary words, boys, we need to know what they mean. They are not interchangeable. Each of these, in fact, has a different meaning and a different application in certain contexts. So, like when I'm using the word reciprocal, that means do what with the fraction? Flip it. If I'm doing opposite, that means change the sign. When we talk about inverse, okay, so a lot of times like adding and subtracting are inverses. Logs, we'll learn about logs. Logarithms and exponents are inverses. So like the inverse is sort of this notion of undoing something, right? And then, of course, conjugate, like we talked about, a binomial has a conjugate where you change the sign in the middle. So what type of process am I going to undergo on the numerators here? Starts with a D, ends with distributive.
Distributive.
All right, well, good. We'll use the distributive property. Now, that's kind of a trivial distribution, right? Because what's the original numerator? 1. So BJ could tell us our new numerator is going to be what? We're just multiplying by 1, so it doesn't really change. How about we just rewrite the numerator? All right, 1 times. So I did call on you because your head was down. Make sure you understand. So we just got 1 times this binomial. I said we're going to use the distributive property. We won't really have to because it's a 1. So it's just square root of 2 times square root of 2 minus square root of 3. If this had been something else, heck, maybe like another binomial, then we would use the FOIL. We'd use the FOIL process. All right. How about on the denominator right here? Andrew, should I FOIL that? Trick question. I shouldn't FOIL it. I should FOIL it. Why? Because they are C word? Conjugates. Good. So what's square root of 2 times square root of 2? This is what Sebastian and I did a minute ago. 2. And what's square root of 3 times negative square root of 3?
3.
What kind of 3?
Negative 3.
Negative 3. And then lo and behold, hot diggity dog, this winds up equaling square root of 3 minus square root of 2. Which I find to be pretty nifty that big ugly fraction, but through the process of rationalization, looks like that nice, simple.
How did you get there?
You tell me, Mitchell. You tell me.
Well, is it you saw the 6 in the bottom?
You got a what on the bottom?
No, never mind. Negative.
Aha, there we go. That's what I want you to get at, right? So you have this simplifies down to -1. Now dividing by -1 just means we change the signs. So that radical 2 becomes negative, that radical 3 becomes positive. And I don't know about you, but I like my positive terms to come where?
In the middle.
In front.
At the front. At the front. Okay. There's only 2 terms. How could one of them be in the middle, for Pete's sake?
I thought you were
Goodness.
talking about the 9.
Oh, no. All right. So rationalization, y'all probably have a little practice doing that. That's a valid skill to be good at. But we're getting close to the end of class. Let's practice doing some addition and subtraction. Okay. Kenneth, what are the requirements for addition and subtraction of radicals? Root. They got to have the same root and then the same radicand. Very good. Do these 3 have the same roots? Try again.
Yeah.
They do have the same roots. Do they have the same radicands? So I guess I'll just throw my hands up and say, oh, you can't add those together. Simplify them first. What goes into 45, class?
5.
Try again. Thank you. 9. I'm looking for perfect squares. Yes, 5 goes in. Yes, it does. Okay, so this one would be 3 square root of 5. Okay, class. Be smart about this one. What goes into 80? The words coming out of your mouth at best be perfect squares. I like 16. 16 goes in how many times?
5.
So this is 4 radical 5. And then all of a sudden, woo, we got the same radicand. So we just tally up their coefficients. 3 plus 4 is 7, minus 2 is 5. So we got 5 square root 5. Now, I highly recommend, let me dial this down just a little bit. I highly recommend, if you are currently in a state of what? From here to here, from green to green, we need to practice a little bit. Okay, we need to practice a little bit. I don't necessarily know where all of you friends are, but I know where you need to be. And you need to be comfortable going from radical 45 to 3 radical 5 without a whole lot of ballyhoo, without a whole lot of pomp and circumstance. Be able to simplify your radicals. Now, sadly, our nice $150 calculators won't do that for us. The internet will, I know, but I want you to be able to do that in your brains. That's all I've got for you guys today. I'll have a little assignment on ye old Delta math. And in the meantime, live Jesus in our hearts forever. About a minute or two. Yes, sir.
I found out a way to download things on the.
Speak up.
What the Central Path we do next class?
Oh, BT Dubs. What also is due next class? What's due Friday? Problem set. What's today? I lied. I said Friday. I meant Thursday. Thank you so much. Yeah. So y'all got a Delta math that's going to be due, and you've got a